In these problems, we want to simplify and write the answers without exponents. So the key is to understand that we have a fraction as an exponent. That's called a rational exponent. So if we have a number, I'll call it x, and let's say it's raised to the m over n power, then a fractional exponent means we could actually rewrite the expression as a radical. And the number that is in the denominator, in this case n, becomes the index, becomes the index of the radical. And then the number in the numerator, in this case the m value, becomes the exponent, like so. And you have two options. You can put the exponent inside the radical, like I've written here, or you can write it as the nth root of x, all raised to the power of m. So if we take a look at the first example, which is 1 divided by 27 raised to the 4/3 power, the denominator of the exponent fraction, the fraction in the exponent, becomes the index. So this is going to be the cubed root of 1 over 27 raised to the 4th power. Now, if I raise 1 over 27 to the 4th power, that's going to require me to eventually do 27 to the 4th power, which is going to be a very large number. And if I'm trying to do this without a calculator, which most likely I am, that's not going to be effective. So rather than writing it to the 4th power inside the radical, it's going to be much easier to compute if I compute the cube root of 1 divided by 27. I'll compute that value first, and then I'll raise the result to the 4th power. So look at what happens. When we have the cube root of 1 divided by 27, we'll take the cube root of the number in the numerator, which is the cube root of 1, divided by the cube root of 27. We will go ahead and simplify both of those values and then raise the result to the 4th power. The cube root of 1 is 1. The cube root of 27 is 3, so that gives me 1/3. And then we'll raise 1/3 to the 4th power, which means we are going to raise the numerator to the 4th power, so 1 to the 4th power, as well as the denominator, which is the 3 raised to the 4th power. And then you have to remember 3 to the 4th power is 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So the exact answer here would be 1 over 81, 1 divided by 81. Let's take a look at the second example. Now the second example has a fractional exponent, but it also has a negative exponent. So this requires that we remember another property of exponents, which is what happens when we have a negative exponent. So x raised to the negative 1st power turns into 1 divided by x to the positive 1 power, which we just write as 1 over x. So if I had x to the negative 2 power, that becomes 1 over x raised to the positive 2 power. So let's look and see what happens if we have x to the, let's say, negative 1/2 power. So the negative exponent makes it 1 over. So that would become 1 over x to the positive 1/2 power. And then, as we just showed in the previous example, now we have a fractional exponent, which is going to turn that into a radical. The denominator becomes the index, so it's a square root of x to the 1st power. And when we have square roots, we don't write the index of a 2, and we also don't write exponents of 1. So x to the negative 1/2 power is the same as 1 divided by the square root of x. So now let's look at our example, which was 625 to the negative 3/4 power. So 625 to the negative 3/4 power, we're first going to deal with the fact that the exponent is negative. So negative exponents, they do not become negative numbers, they become fractions. So a negative exponent causes this to be 1 divided by 625 to the 3/4 power. Then we see that we have a fractional exponent, and the fractional exponent causes the denominator to turn into a radical. So the denominator of this fraction is a 4, so that means we have an index of 4, and that would be 625 to the third power. Well, once again, there's no way that I'm going to compute 625 to the third power easily without a calculator. So this is where I'm going to choose, rather than putting the exponent of raising it to the third power, rather than putting that inside the radical, instead I'm going to put it outside. So I'm going to compute the fourth root of 625. I'm going to compute that first, and then I will raise the answer to the third power. So it turns out that 5 times 5 is 25. 25 times 5, so 5 cubed, is 125. And if I multiply that by 5 one more time, that would be 625. So the fourth root of 625 ends up being 5. And then we'll raise 5 to the third power, so this will leave me with 1 over 125. So my answer is 1 divided by 125.